Alright, this live streaming has been started. Alright, so as per your request, guys, in this video I want to start a series on recursion and backtracking. Today we're going to solve two basics recursive problem: factorial of a number and nth Fibonacci number. So let's start with the factorial of a number. How to find out factorial of a number using recursion? How to find out factorial of a number using recursion? Let's see. Do you know what is recursion? Recursion is a process in which we call a function inside the function. We call the same function inside the function. That is called recursion. For every recursive function has two properties. So every recursive function has two properties. One is called base case, and the second one is called recursive case. So for examples, if we have a function if n, if we call this function with n, this function will have a base case. The base case, when the base case satisfies, the function stop calling itself. Stop calling, we can implement base case using if conditions, and we have a recursive case where we call the function. This is the basics of recursion. Now let's see how to find out factorial of a number using recursion. Before that, after showing you how to find out the factorial of a number, I will show you how recursion works internally. So how to find out factorial of a number? So factorial of a number. Let's see how to find out. We can find out factorial of a number using loop easily. In this video, I will show you how to use recursion to solve this problem. Let's assume we want to find out the factorial of number 5. N equals to, let's assume 4. We have n equals to 4. We have to find out the factorial of this number 4. How we can find out the factorial of this number 4? Okay, so what is the factorial of number 4? So factorial of 4 is, we have to multiply from 1 to 4. So 1 times, 2 times, 3 times 4. So it's equal to 24. So the factorial of 4 is 24. If we have n equals to 5, then what is the factorial of 5? Factorial of 5 equals to 1 times, 2 times, 3 times, 4 times 5. That's equivalent to 120. So how we can find out the factorial of a number? Do you see any pattern here? If you're a beginner of recursion, if you're beginner to recursion, no problem. Let me show you how to do this. First, what we will do, we will try to break the problem into smaller pieces. When we cannot break our problem into smaller pieces, we'll start solving the problem. Okay, let me show you what I mean by this. First, we have 4. So we have here 4. Now what I'm going to do, I'm going to just break this problem, something like this. So first, what I'm going to do, I'm going to break this problem. We have n equals to 4. First, I'm going to multiply 4, and then I'm going to call a function with by subtracting 1. So we have now 3. We have to solve this problem. If we can find out the solution to this problem, then we can solve this. We can find the factorial of 4. Okay. In order to find out the factorial of 4, we have to first find out the factorial of 3. Now let's break this problem. So here what I'm going to do, I'm going to find out the factorial of 3. So we'll multiply 3 and we'll just subtract. Now we have a 2 here. Now what I have to do, we have to find out the factorial of 2. In order to find out the factorial of 3, we have to find out factorial of 2. Let's break this problem into smaller pieces. So in order to find out factorial of 2, we have to find out the factorial of 1. We're just subtracting 1. Now we will have a base case. We're calling this function recursively. We will show you the code. I will show you the code. Don't worry. Now we're going to break this problem into smaller pieces, but we will have a base case. If we find out our number becomes 1, if a number equals to 1, we will simply return 1. This is our base case. And we're calling this function recursively. Something like this. If n, and here n minus 1. We're calling this function recursively when the base case satisfies, this function gets value. Okay, I'll show you the entire code, how to write this code and how it works. I will show you, and also I will show you how recursion works internally. Just bear with this video. So we will have a base case. When we have n equals to 1, we will just return 1. Now we find out a value here. So this function call will be replaced with a value. It will return a value which is 1. So if it's return a value 1, so we get here 1. Now let's find out the value here. So if we calculate, we get here 2. Now for this function call return this value. So it will return 2. Now this will be replaced by 2. Now we have to find out the factorial of 3. In order to find out the factorial of 3, we have to multiply this 2. If we multiply this 2, what we will get? 6. So this function will return 6. Let's return here 6. So this will be replaced by 6. So what we will get now? We get here 4 times 6, which is 24. And this will be returned. This is our factorial. For a better understanding, let's take another example. Just bear with me. This is not difficult at all. If you're beginners, it might take a little bit of time. Just bear with this video. Let's assume now we have n equals to 5. So first, what we will do in order to find out factorial of 5, first we're going to find out the factorial of 4. We'll call this function. We can rename this function to fact. Let's call it fact. So it's better naming convention. Now we have to find out factorial of 4 in order to find out factorial of 5. We know that the factorial of 5 equals to, we can write it something like this. 5 times 4 factorial. Can you write it out something like this? Yes, we can. So now we have to find out the value of this value, 4 factorial. So in order to find the value for 4 factorial, what we will do, we have to find out the value for 3 factorial. Am I right? So let's call here. In order to find out the value for this factorial, 4 factorial, we have to multiply 4 times fact 3. In order to find out the value of this factorial, factorial 3, what we have to do, we have to find out the value of this factorial. In order to find out the value of this factorial 3, we have to find out the value of 2 factorial, if I'm not wrong. Now here, so let's do the same. So 3 times 4, 3 times a fact of 2. So now, in order to find out the value of 2 factorial, what do you have to do? We have to find out the value of factorial 1. So 1 factorial. If I'm not wrong, so we have to return. We have to find out the factorial value for this. We know that the value of this factorial 1 is, we know for sure that is 1. or we can go further if we want. If we want, we can go further. So here, in order to find out the value of this factorial 2, we have to find out the value of this factorial 1. If we want to make this 1 as our base case, we can do that. We know that the value of this 1 factorial is 1. So we can just stop here. We know this is your base case. Now what I'm gonna do, I'm gonna just return here 1. Instead this, we can return here 1. If we return here 1, what we will get? We'll get 1. 2 times 1 equals to 2. So here we'll have the value 2. This will be replaced with 2. 2 is the value of 2 factorial. So let's replace here. First, let's show you here. Then I will show you this code. So here we will have 2. 2 times 3 equals to 6. So here let's replace this value with 6. Now 3 factorials equals to 6. So let's replace with 6. Now let's calculate this value 24. So this will be replaced with 24. So 4 factorial equals to 24. Here we have 4 factorial. So let's replace that with 24. Now let's multiply this. What we will get? We will get 120. So let's replace this 120. Now can we see that we have the value here 120, which is the factorial of 5. I hope you have understood this concept. Now let's do the same here. What is the value? This is our base case. Okay, so let me write out here the pseudocode so you can see what's going on here. This is not difficult at all. If you're beginners to recursion, I think it will give you a very, very interesting deep knowledge. If you are not advanced in recursions, if you're beginners, it will give you the insight. Now here, let's write out the pseudocode. So let's assume we have this factorial n. We call this function. This is your function. Now let's make our base case here. If n equals to 1, then what we will do? Simply we will return 1 because we know that the factorial of 1 equals to 1. Now here we will have a base case. This is our base case. Now let's write out recursive case here. So in our recursive case, what I will do, we will return a value. We will return a value after computing. So n times factorial n minus 1. This is our pseudocode. So here at this point, we will have, when we're calling this function recursively, we will have here a value 2 times 1. This is your base case. It will return 1. So here we will have the value 1. So when you call this function with 5, we'll have our first call this function. We have to call this function with 5. So factorial of 5. In order to find out the factorial of 5, we have to call this function. In order to find out this value of factorial 4, we have to call this function, then this function, and so on. When you reach this base case, it will return 1. So this part will be replaced with 1. 1 times n. Here n is 2. So 2 times 1 equals to 2. It will return 2. Okay. Then here it will be replaced with 2. So 3 times 2 equals to 6. It will be replaced with 6. 4 times 6 equals to 24. Here we will have 24. It will be replaced with 24. 5 times 24 equals to 120. So factorial 5 equals to 120. This is the core intuition. Now how it actually works. Recursion internally uses a stack data structure. Remember it, recursion internally uses stack data structure. Let me show you how it actually works. So we will have a stack here. Let's assume this is our stack data structure. We know stack support leaf principle, last in first out. Last which value inserted at the last, that goes out at the first. So this is called leaf principle, last in first out. The last inserted items will be removed first. So first we call this function factorial 5. So here we will have factorial 5 in our stack. So fact 5. Then we have called this function. This is the state of our recursion. So here what we will have in our recursion, we will have then factorial 4, then factorial 3, then factorial 2. Then when you call this function, it will just return, because it will return. So for this function fact1, this function placed on stack, and it is satisfy the base case, so it will return 1. Then it will be replaced with so here it will be something like 2 times fact1. So this one will return 1, so it will return 2. Then here for fact2, this function were at this stage, and then it will return 2. Okay, it will return simply 2. Then it will calculate this value 3 times factorial 2, and then it will be just calculate this value, and so on and so forth. At the end we will get here 120. So a recursion uses stack data structure. The last function will goes first. It will pop first, the last function. And this is how recursion works. I hope you have understood how recursion works internally. And this is the core concept of recursion. I hope you have understood. For every recursive function call, we have a base case and we have a recursive case. In the world, if you saw any recursive functions, you will saw two things common: recursive case and the recursive case and the base case, where the function stop calling, and recursive case where the function is calling itself recursively. I hope you have understood factorial of a number. Now let me check the chat forum if you have any question, guys. Let me ask you, do you have any question? Do you have any question? If you have any question, you can ask your question here. I see there is no question. So let me show you the code for this recursive solution. This recursive solution of a factorial finding. So here I've already the code. Let me remove everything else from here. I'm sorry, I have some code here. All right. So this is our main method. We have just here only one method, main. So let's create here a function factorial. Let's call it public static int factorial. This function takes one parameter, the number itself. Inside here we have a base case. If n equals to 1, what we will do, we will return just 1. This is our base case. Now let's write to the recursive sketch. In the recursive sketch, what I have to do first, we have to let me show you here. N times, we have to call the function factorial with n minus 1, and we have to return this value. This is called the recursive catch. Hope you have understood the recursive catch and base case and how to find a factorial of a number using recursion. And here I'm going to call the function factorial. Let's provide here 5, and let's print the value whatever the function return. Okay, let me run this code. The code is pretty simple. It's written 120. This is the factorial. This is how we can find out factorial of a number using recursion. I hope you've understood this video explanation. Let me check here whether this video is working or not on my phone. So take a break. Let me check it whether it is working or not. All right. Okay, I think it's working just fine, and there is no issue about it. Now I can move to the next question, finding the Fibonacci number. This question on LeetCode, I saw on LeetCode. Let me check here it is working or not. Okay, it is working. Let's move to our next question. Fibonacci number. The Fibonacci number, commonly denoted Fn, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones starting from 0 and 1. That is, we are given this formula here. If we're given 2, we have to return here. If you're given 2, we have to return just 1. Okay, let me explain you what does it means by this formula here. Okay, I saw there is no viewers actually. Okay, it will increase day by day, no problem. Now here, let me show you what it means by the formula. So what is the problem? The problem statement. Let me show you first what the problem statement is. Okay, let's go to this. Okay. Now let's see this problem. Fibonacci number. Fibonacci number. So the Fibonacci number start with 0 and 1. Then the next number is the summation of previous two number. So here we will have 1. 0 plus 1 is 1. Now here 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 3 is 8. Now 5 plus 8 equals to 13. 13 plus 8 equals to 21. And so on. This is called the Fibonacci series. In this problem, if you are given n equals to 0, we have to return the 0th Fibonacci number. If you are given n equals to 1, we have to return the 1th Fibonacci number, the Fibonacci number we have at this position. Then if you're given n equals to 2, we have to return this number 0, 1, 2. So if you're given n equals to 0, you have to return 0. If you're given n equals to 1, we have to return 1. If you're given n equals to 2, we have to return 1. If you're given n equals to 3, we have to return 2. If you're given n equals to 4, we have to return 3. If you're given n equals to 5, we have to return this number 0, 1, 2, 3, 4, 5. 5. If you're given n equals to 6, we have to return 8. If you're given n equals to 7, we have to return 13, and so on. So based on this given value of n, we have to return the value of from our Fibonacci series. This is the problem statement. Now how we can solve this problem? Now let me show you how to solve this problem using recursion. Let me erase everything from screen. Okay. Now let's see how to find Fibonacci a number. So let me write it the series here: 0, 1, 1, 2, 3, 5, 8. Then here 13. 21. Let me write out this. This is our Fibonacci number series. Let's assume we're given n equals to 7. N equals to 0, 1, 2, 3, 4, 5, 6, 7. Let's assume we're given n equals to 7. Now we have to return this number. How to find out this number? Let me show you how to find out the number using recursion. So for 7, we have to find out, in order to find out the 7th number in our Fibonacci series, first we have to find out the previous two number for sure, right? The previous two number. So how to find out that? So let me find out the previous two number. In order to do that, first what I'm going to do, I'm going to move to the 6th number. What will be at the 6th position? So here let's move to that 6th position. And we have to move to this position, so which is by subtracting 2 we will get here. Here we're subtracting 1, and here we're subtracting 2. So what I will get here, we will get here 5. Here we have again two choice. In order to find the 6th Fibonacci number, let me write out here the number itself. In order to find out the 6th Fibonacci number, we have to find out the Fibonacci number at 5 and at 3. Okay, so we have to move to 5 and we have to move to at 4. Then if we find out the Fibonacci number of 5 and 4, we can just add that, then we will get the Fibonacci number 6. Now in order to find out the Fibonacci number of 5, we have to find out the Fibonacci number of 3 and 2. The Fibonacci number at 4 and 3, at position 4 and 3. So let's go there at 4 and at 3. If we find out the number at 4 and at 3, then we can just add that number. Then we'll get the Fibonacci number at 5. Now for 4, we have to find out the Fibonacci number at 3, and we have to find out the Fibonacci number at 2, at the second position and third position. Now in order to find out the Fibonacci number at this position 3, we have to find out Fibonacci number at position 2 and 1. So let's do here we have to find out at 2 and at 1. Here we'll have a base case. In this problem, we will have two base case. If n equals to 0, what we will do, we will just return 0. If we saw n is less than or equals to 2, it means that the value of n should be 1 or 2. In that case, what we will return? We will return just 1. So this 2 would be our base case for this problem. So for 2, what we will return? We will return 1. For 1, also we will return 1. Now in order to find out this value at position 3, we will just add whatever value we have for at this at second position and at first position. So what I'm going to do now, I'm going to just add this two value, 1 plus 1 is 2. So here we will get 2. So for sure that we know that now at third position we should have the value 3, at value 2. Now let's find out the value at this position 2. This is our base case, so we will return here 1. So 1 plus 2 equals to 3. So in order to find out at value at this position, we have to find out the value at 2 and 1. We already at 3 and 2, we already find out the value 2 and 1. So we'll just add the value and then we get here 3. So here we have the value 3. Similarly, we will find out the value here 2 1. Similarly, what we'll get 1 1, so we'll get here 2. So at third position we'll have the value 2. So just add this to value 3 and 2, we'll get here 5. Now we have to find the value right here. We have to repeat this entire process here again. This entire process right here. So here what the value we will get? We'll get the value 3. So let me write the value 3. I'm not going to waste your time by repeating the same task. We should have here the same process, exactly same process we have here. So we'll just add this two value 5 and 3. So at fourth position we have the value 3. We clearly saw that. And at fifth position we have the value 5. So we can find out the value at the sixth position by just adding the value at fifth and 4. If I'm not wrong. Alright, so that's what we're doing here. 5 plus 3 equals to 8. So here we'll have 8. So this is our value. Now let's find out the value at 5. Because in order to find out the value at 7, we already find out the value for 6. Now let's find out the value for 5. At index 5, we have to find out the value. We already know this value 8. Now we have to find out this value at this position. How can we find out that? We have to repeat this process, this exactly same process right here. Exactly same process. What do you get? We will get here the value 5 for sure. If we do the same process right here, we'll get the value 5. Now if we add the value at fifth position and at sixth position, then we will get the value at the seventh position. So we will just add this to value 5 and 8, which is 13. So let's add here 13. And this value will be returned if we call this function, if we call the fifth functions, every function with 7, it will give us the value 13. This is how this Fibonacci number. This is how we can find out the Fibonacci number. So this is how we can find out the Fibonacci number. This is the recursive case. So here, this is called base case, and we will have a recursive case here. We'll have a recursive case. So in recursive case, we will return, and here we will call the function. If the function is n fib, then fib minus 1 plus fib n minus 2. This is what it is. And here we'll just call the function fib with value n. All right. So this is our code for recursive for this solution. And here you saw that we're repeating the same work multiple times. Here we have this process 2, and here we have the repetition. Here we have for 3, and here we have to repeat it again. Here we have 5 for 5, we have to repeat it again here. And that's worst complexity, we can say, if we think about the time complexity. This is the worst thing. So if you want to optimize it, we can optimize it using a dynamic programming or using caching. We will store the value for, when you find out the value for here, for this 3, we'll just store the value in a dynamic programming table or in somewhere else. Then if we find out the same subproblem for 3, we'll just return the value. We'll not repeat that again. So this is how we can reduce the computation. We can make it efficient. But in this video, we're just talking about recursion. I'm not going to talk about the dynamic programming optimization. In the future, I will create a video playlist on dynamic programming. On that, I will show you how to optimize this algorithm by just storing the result of subproblem in a table, and then you can use the pre-computed results to do not compute if we find out the same subproblem again and again. Okay, this is not the optimization video. In this video, I'm just talking about how the Fibonacci number works and how the recursion works. I hope you understood how to find out nth Fibonacci number. Now let me show you the algorithm. If you guys have any question, you can ask your question. I'm ready to answer your question. Actually, there is no questions and there is only one viewers. I think in the future it will increase. Now let's see the algorithm for this Fibonacci number. So let me write the algorithm right here. All right, let me write out the algorithm here. I'm sorry. Okay, so first thing we have to take our base case. If n equals to 0, we already show you that for base case 0, what you will return, we will return just 0 if the given number is 0. If n is less than or equals to 2, if this condition is evaluated to, it means that the value of n is not equals to 0, the value of n should be 1 or 2. If that is the case, we will return just 1. Now we will have here two choices. We have to move one step and we have to move two steps. So let's create two value. So for one step, step 1 equals to fib n minus 1. This is our one step. Now let's do here two step back. So step 2 fib n minus 2. And here at the end, we'll just, if we find out step 1 and step 2 for a specific position, we'll just add the step 1 and step 2. Then we'll get the value for our current position. So step 1 plus a step 2. I hope you have understood. This is our algorithms. This is how this algorithm works. This algorithm will take, actually I forgot to explain the times complexity. The time complexity should be 2 to the power n, which is exponential in time. We can optimize it to linear time complexity by using the concept of dynamic programming. In the future, I will create a playlist on dynamic programming, entire playlist on dynamic programming. But for this video, I'm just talking about recursion. So I will not show you here the optimized approach. And the space complexity is big of n. The space complexity, you might think for the recursion call, we should have 2 to the power n. No, we don't have that. For the worst case, we will have n number of items on our stack. We know that recursion is a stack internally. So we will have the height of our stack. We will have the element on our stack, the height of our recursion tree or our decision tree. The tree we just drawn, that is also known as decision tree. So the space complexity is of n, where n is the given number. I hope you've understood this video explanation in a very high level. Now let me compile this code. If I run it, if there is something goes wrong, I'll fix that. All right, now let's submit it. Successfully submitted. We have solved this problem. I hope you have understood how to solve this problem efficiently. Sorry, not the efficient solution, just the solution we can, just the solution that we can solve using recursion. All right, so this is my solution to this problem. Still, guys, if you have any question, if you have an issue understanding this video explanation, let me know. I'm here to give. I'm here to help. Alright, I saw there is no questions actually, and now I wanna just end this live streaming right now. Thank you for joining in. See you in the next video. Till then, take care.